right, Stefan. Thank you very much for taking your time and inviting me here at univerCell in the north of Germany to a tour, a factory tour, as well as a conversation with you about univerCell, but also about the current status of our industry.
Yeah,
Before,
it's a pleasure to have you here in Flintbeck.
thank you. Yeah, and we just toured the building, and you showed me the different tasks that you have ahead of you, like the development projects, like the new cells that you show here, but also all the production equipment that you are have already installed, but that you're also soon to be scaling up, as you explained me. But before we come to that, I would like to understand how your personal path into the field of battery innovation went. So where did it all start?
Yeah, so let's take it really from the start. So I was trying to, or at the end of my school career,
Okay.
I looked for something that was easy for me and that I wanted to study.
Yeah.
And that, so there was two things, physics and chemistry, which were always the things that I liked the more. And so I studied chemistry then, because physics was for me sometimes too big, and I didn't had a application in mind with the physics
Oh, okay.
studies. So this is why I decided for chemistry.
Mm-hmm.
And I studied here in Kiel chemistry, because it's very near to the Baltic Sea. And besides my studies, I wanted to go kite surfing. So this
You were
is
a professional kite surfer, right?
yeah, I was a professional that days, and like for 10 years I was professional. So this
Wow.
was like my kind of job besides the studies. So I financed my studies with professional kite surfing, which I think is very special and very unique,
Yes.
but a lot of fun. So I traveled the world and was everywhere on the different beaches around the world. So it
That's
was a lot of
inspiring.
fun. Yeah, and then my first touch point was my diploma thesis. So at the end of my chemistry study, I was doing synthesis of nanoparticles, which could be used. So they were also magnetic.
So silicon nanoparticles, or
No,
what
it
was it?
was some kind of iron oxide stuff. So it was
Ah,
also
okay.
conversion materials,
Mm.
but also anode,
Mm.
but very exotic. It was more basic
Okay.
studies. And you could use it for like lithium ion batteries as an anode,
Yeah.
or use it as for MRT uh, uh,
Okay.
use, like
Magnetic
you.
resonance. You mean tomography?
Yes,
Ah, okay.
exactly. So you could also use it for that. But I decided for batteries to try to bring that into that application.
Yeah.
That was during my diploma thesis, and then I could like stay on the topic and
Mm.
spread it over to my PhD thesis.
Mm.
And then my PhD thesis was obviously only about lithium-ion batteries,
Yes.
and but it was very basic, fundamental research. So I did a lot of synthesis, and also I did a lot of work at synchrotron.
Mm-hmm.
So I looked at the battery
So in
while
Hamburg at Dizzy, or?
in Hamburg, in Berlin, I was also in UK at the Diamond. So
Oh.
there was a lot of applications for like looking into the battery while it was charging and discharging. So like in operando spectroscopy, like XRD
Mm-hmm.
and things like that. So that was my PhD thesis, and after that, I joined the company called Custom Cells, which was that days. It was a spin-off from Fraunhofer Institute, and was very early stage, I would say. So
What year is that? What we're talking?
that was 2016,
2016. Okay.
and we were like really 7, 8 people in the container, and then we had a small production site where we could like go in and do some electrode coding and some small cell building.
Yeah.
So that was a very early stage when I joined Custom Sites, but it was a lot of fun, exciting time, because then we grow. So it was that days when batteries became more and more popular.
Mm.
So we grew very fast. So in 3 years, we were more than 60 people. I was CTO. I was responsible for a lot of things, like for all the research development, but also for purchasing new materials. From time to time, I was even for the complete production responsible. So it was a lot of fun. And what we did that time was a lot of prototyping for automotive industry.
Mm-hmm. So for the German OEMs or also internationally, what was the focus?
Focus was German, but also some European
Okay.
OEMs as well. And yeah, that was the exciting first steps of building prototype batteries, the first like functional cell. That was our main business.
Yeah. And then you matured at custom cells, like personally, but also as a company. And then, as far as I know, at some pivotal moment, you decided to start your own business with univerCell.
Yeah, exactly. So that was a time when our customers, so the automotive OEMs, started to bring up their own center of excellence or whatever you want to call it. Like they want to also have the ability that we did at custom cells
The in-house capabilities
in-house.
to
Yeah.
do their prototyping and pilot testing.
Yeah.
Mm-hmm.
And I was wondering how to go on. So it was a really like open discussion how we want to go, where we want to go.
Yeah.
And my idea was like scaling up because I saw that we did the small prototypes in-house, but there was nobody can scale it up, like build higher quality prototypes. It was always in this lab scale until pilot. And then there was nobody in Europe, at least, who could scale up. And then was the big Asian players. They doesn't want to scale up with stuff like coming from Germany or Europe. They said, no, we are doing our own development.
So when you're talking about scaling up, you don't mean a small series production. You mean a gigafactory, right? On the gigawatt hour scale per year production capacity.
Yeah. Also to like get the quality on the one hand side, but also to get like the economy of scale. So my idea was then to build a company into exactly this into this between the big gigafactories and the like pilot production,
like 2-digit gigafactories, and then something in the kilowatt hour or megawatt hour range.
I think the main point here is that we as univerCell are focusing on special application, we call it. So we are delivering not for mass market automotive stuff, we are delivering for all the other smaller market segments with specialized solutions. And we are doing that not in megawatt scale, as you said, we are doing it really in gigafactory scale. And what we are running is like a complete flexible gigawatt production, which is very unique, I would say.
I wanted to pause here for a second because this is actually, I think, to be emphasized. It's a flexible giga scale factory. And I think a good example for this is you have the pouch cells, and now you're coming up with cylindrical cells, where many people may ask, why is this not a 46800 or 461,200 or some other type of cell, but the classical 21700 is, I think, the format that you use here right now?
Yes.
And this is only one aspect of your competence portfolio. You still have the electrode development and production for other customers who are building up their cells with it, correct? So there are two main segments that you provide your competence to?
Yeah. So when we founded the company back in 2019, it was a question how we want to do it. So you can do it like in a way that you raise a lot of money at one time, and then you're doing a lot of the supply chain. So like
A little bit
doing
like Northvolt.
electrode.
think.
Yeah, Northvolt was very broad, like from raw material, electrodes, cells, modules.
Mm-hmm.
And we tried to separate something inside the supply chain, and we decided on the electrodes.
Mm-hmm.
Because I have a very strong chemical background.
Yes.
My other co-founder has an engineering background. So if we said, okay, if we bundle our competences, electrode is the one that we want to deliver first for customers.
Mm-hmm.
So what we did in the beginning is we said, okay, we are just doing a small piece of the supply chain, the electrode. So we only installed a pilot and laboratory just for electrodes in a very early stage. And then we just delivered electrodes to the customer.
Mm-hmm.
And the concept behind is like, on the one hand side, bridging the gap because everything is raising up. So it was good that there's also the way that you can like source just electrodes. And then we have some other customers that are not interested in the electrodes. They are just so they are still buying and will buy also for the next 10 years electrodes from us. And the reason behind is like they are coming from the, I would say, more engineering part. So they feel very comfortable by building cells, but doesn't feel comfortable with the chemistry part, which is in the electrodes.
Yeah, and I of course don't know who the customers in particular are that you're talking about, but in Germany specifically, the competence, the automotive industry, is more on the assembly side, on dealing with mechanical parts. Whereas in the battery sector, we now have a domain cluster of different competences. We have the mechanical characteristics, like this has to be a mechanical integer system, but we also have the chemical side, we have the electrical side, we have a huge thermal side that has to be regarded as well. Well, we have that in the automotive industry as well, but this comes on top of the standard mechanical engineering. And I see the point that you made there, that you are filling this gap, this competence gap, which has emerged with this new technology, where we have not inherently built up European competence, right?
Yeah, exactly. And also like another aspect was like starting in a small step and also showing investors turnover. That was also a mission that we wanted to accomplish from the very early beginning, because we wanted to go step by step without investing hell of a money. You still have to invest multiple million of euro, but it's not like the very, very large wheel that you're turning. It's still step by step.
It's Luke who from Electroder, who I had recently on the podcast, mentioned a word that he called acceptable risk. Like he coined that term, and I really like that because it says something. Innovation is risk. There's just it's in the definition. But the question is, what is the magnitude of it, right? So the magnitude is the one, but what is the duration that your stakeholders, your investors, were able to allow you to grow? So where we're talking about 2 years, 3 years, how long do you see the time frame also for new companies and entrepreneurs that are coming up in our field? What should be the payback time? Within how many years should you prove your concept that you are economically viable?
I think we made it like with the steps by step solution very fast. So we roughly, I would say, 1 to 1.5 year. We could show that turnover and cash flow positive is possible, and then we move to the next step. So this is how we did it in the past.
Yeah. In the tour that we went through, you showed me, I think, the different steps. So you started off in 2019 with a pilot line that you yourself and with your colleagues, also with Marius, I guess, built up together. And then you transitioned over in 2020, 21 to the larger scale factory, right? And that was the next phase. So is this kind of the cycles that you went through, correct?
Yeah. So we started with laboratory and pilot. Then we got to the pouch cell because that was the next piece that we needed also to like prove our customers that our electrodes are really working. So we wanted to prove it in-house also.
Mm.
And not only in coin cells, we want to have like a real production line to prove that the electrodes are good because of quality point, but also like having the ability to prove it in a real cell. So
Mm.
everybody which is doing research development knows how you can make your cell a little bit better if you're
Yes.
on R&D scale. But
Yes,
if
of
you're
course.
in such a large cell which has like 30 to 70 ampere
Yeah,
hours,
for these guys, how many gigawatt hours of cells are we talking there?
so we can build from this one 1.2 million cells per year, which is still in a 3-digit megawatt
Mm-hmm.
hour range, so not giga,
Mm.
but it's still a good amount of cells,
Yeah.
and we are using this production line very different. So we are using it very flexible. So like having different type of electrodes, electrolytes, separators, or ingredients of the electrode.
But not the mechanical design, right? I think that
No, we
is the
stay
cell
always
format
with
is fixed.
with the cell. The
Mm.
only thing that we are a little bit flexible is the height.
Mm.
So
Okay.
we are making very thin cells,
Mm-hmm.
and the standard value is 12.5, but
Mhm.
we can also make it thicker.
So like 40 to 50 amp hours, or
Yeah,
maybe
so if you have LFP chemistry in it, it's more like in a range around 30 ampere hours. If you go to NMC plus high silicon content, you can reach 70, 80.
Mm-hmm. If we're talking about chemistry, and I know you have a profound knowledge about that, so how would you describe the different chemistries at the moment? What are their potential? And maybe also to segue over to this other cells that we have here, the cylindrical cells. Is it all the same chemistry because they have different applications? So can you link the material performance with the products that you develop at the moment?
Yeah, sure. So this is a heavy duty cell.
Yeah.
It's for long life and also wide temperature range. So if
Mm.
you have really rough applications where you need a cell that is like functioning all the time at any condition that is coming from the outside, whether it's hot or very low temperature.
Yeah.
So there we are using LFP
Mm-hmm.
in it as a cathode.
Mm-hmm.
For the other two, the high power, high energy cell, we are using NMC
Mm-hmm.
as a cathode with a high nickel content plus a silicon graphite anode.
Mm-hmm. Okay. So no silicon in here?
A little bit, but less
Okay.
than the others.
All right, to make it more sturdy, because silicon has still negative implications on the cycle life.
Yeah.
Right. Okay. So this was the product side, and now the question is how you deliver those cells. Like, what are your manufacturing technologies that you're using? Are you using, like, starting from the mixing, going to the through the coating and drying to the calendering and stacking later on? So on this expedition, I'm trying to understand where the competences are for which application. And during our tour, when we visited the pilot line, but also the larger line, you explained me also that you see the mixing processes side by side for their particular applications. Can you explain a little bit how you approach the technology landscapes out there, so all the machine suppliers, and how you adopt it in your factory?
Yeah, so I think, as we said, one big unique point is that Universe is very flexible
Mm.
production. And what we have for mixing is like, I would say most of the things that you can get on the market, we have installed in our facility. Like we have the typical mixing with this large tanks, this what you see like everywhere in every gigafactory. Then we have some extrusion machines where we go with a wet slurry,
Yes.
and then we have also like very high intense shear mixing, which is a special kind of process where you can bring down the mixing time.
Mm.
And it's hardly say you can use this or that. So it depends also on your recipe, on your characteristic of the material. Sometimes, like LFP is not LFP. There's a lot of different types of LFP that you can get on the market, and with
Yes.
some, the one mixing is better than with another mixing process. So there's a lot of experience, a lot of knowledge needed.
Mhm. Okay. Due to your chemical background knowledge and competence, are you also going into alterations of the material, the start of materials per se, like grinding down silicon particles and stuff like that? Are you going in that direction, or is that in a field of innovation where you say, no, this is the chemical companies that are doing that?
Yeah, so normally we are giving them feedback, of course, and
Mm-hmm.
we are discussing it with our suppliers. But this is something that they should do.
Mm-hmm.
And what we want to have the big bag of material, or the bag of material we want to put in our mixing unit, and then we want
Okay,
to go from there. So
gotcha.
it's, in our opinion, not our job to like grinding or doing something like modification of the material. So
Mm-hmm.
this is something what we are discussing with the supplier, and then they are
Mm.
doing it for us.
Do you see the supplier network sufficient in Europe, or you say like you need to source internationally?
We are doing both. So there is a possibility to get complete cell ingredients from Europe,
Okay.
but not in large gigafactory scale. It's still more or less in a pilot or low amount of gigawatt.
Yeah.
And what we are very openly discussing is the pricing with our customers. And there we see customers that are saying, okay, I take the material from Europe and I agree with a higher price.
Mhm.
But there's also a lot of customers that they say, no, we are at the moment not willing to do it. And
Yeah.
I think it's a step by step stuff. I think you need companies like univerCell, which are building cells. We need other companies that are doing the active material. We are needing some refiners, and we are also needing the mining.
Mhm.
And I think it will be not like, okay, we are pushing for one big cell manufacturing company, and then the others will come automatic.
Yes.
I think it's a step by step, and I think every support that can be given from customer side
Yeah.
is needed and necessary, and I think there should be more engagement still,
Mhm.
that companies like univerCell, but all the companies in the supply chain before us
Yes.
can can develop in the future, because at the moment there's a lot of room to expand, and sometimes I have the feeling that there's a lot of discussion about the pricing back
Yeah.
and forth,
Yes.
and it takes long time, and then nothing is developing, because then
Because there's no hope, no motivation to push through this valley.
yeah, and you
Okay.
are running through the valley of death with all the steps. So it's not only the cell manufacturing, which is a valley of death. There's also the same for refining, for
Yes.
cathode manufacturing.
Do you think that we'll have, or do we actually have the competence at the moment in Europe to address all the different needs along the vertical integration, along the innovation chain of batteries? And do you see the potential to, in a reasonable time, so let's say the next 4 years or 5 years, to build up this battery ecosystem, this European battery ecosystem?
Yeah, I think we have the competence, but what we need is like we need some risk takers.
Mm-hmm.
So the risk cannot be taken by one in the supply chain, but the risk has to be divided to everybody, and
Mm-hmm.
it's getting also up to the customer and
Mm-hmm.
to the application. And I
Mm-hmm.
think if we can share the risk, we have the competences, then we can build up an ecosystem.
Mm-hmm.
But if we are not like working on it, it will not happen. Then the Asian will just copy their stuff from Asia, and then
Yeah.
it will be more Asian owned, but maybe local, but not European owned companies.
Yes, understand. What is the role of politics in there, and also governmental funding?
I think it's super important
Mm-hmm.
that they build up a equal or a level playing field. I think is the right word there. So you have to imagine now, yeah, in the US we have the ERA. Of
Mm-hmm.
course, now it's difficult if it still will be there or not, but
Mm-hmm.
we had it in the past years.
Yes.
And in Asia, the complete battery industry, it was not like without support of government. They are pushing super hard for all, like CATL, for example. They are the market leader, and they are pushed definitely by the government
Mm-hmm.
by sourcing raw materials like cobalt from Africa and so on and so forth. So they are supported by government on the political part and on
Yes.
the financial part as well. And I think what we need is the same for Europe, so that we are at least on the same level.
Mm-hmm.
Because what sometimes is happening in Europe is like we have a lot of bureaucracy everywhere, like battery pairs. These things are great. We
Mm-hmm.
have to do it.
Yeah.
But then the battery pairs cannot be the way that just the European suppliers have to do it and have to do all the like calculations and do the work into it.
Mm-hmm.
Then we have to be also like, yeah, like covered from the outside, that not cheap batteries without such a battery PS are entering the European Union or
Mm-hmm.
the Europe.
I think the battery pass is quite a good option that we have in Europe, or not an option, it will be mandatory to get this level playing field. It at the moment has about 1% on the sell price, I think, per kilowatt hour.
Yeah.
What it makes European cells more expensive. But I mean, this euro, I think, is a good investment if we can say, hey, therefore the cells are not just sustainably source the materials, but also protect, or let's say support, our internal market on building up our own industry. So my question to you is in three keywords, or as few as you can. What are the challenges at the moment in Europe that are holding us back from establishing the battery ecosystem?
I think we have not enough political support. So I see it in Germany, for example, just finding a production site. So sometimes things are simple,
Mm-hmm.
and I think like if there's some area where industrial production can still happen,
Mm-hmm.
sometimes you get the impression that it's not the case because there's some bodies living there, which is great,
Yes.
but they are against industrial. Sometimes you have the idea, and I think that it's good to have at least areas. So there's some simple things politics can do.
Mm-hmm.
Then there are some more difficult things politics have to do, like is the financial side. So we need a push on the financial side, because if you look on we had that in the past, like IPCI, TCTF.
Mm-hmm.
So these things doesn't or should not stop. They
Yes.
have to move on, and we have to put even more money into that, because like if we are looking onto just an example, Asia, Chinese government spending like 750 million euro just for solid state development, research development,
Mm-hmm.
and we are not pushing that money at all into the battery. So just there's a huge gap on the financial side. So there has to be pushed a lot of financials also, and we need risk capital, and it cannot come 100% from government or taxpayer money. I totally agree, but we need that also in Europe, because we, like US, I think they are developing still in a good way.
Yeah, they have it more on their identity
Yeah,
to engrave that it's part of their business to fail.
Yeah,
to start off again, to iterate, to optimize, and then to finally make it. I mean, they are also not leading the game on battery production, but still, I think
sure
there
not.
are
Yeah.
in our industry. It's said that at the moment the US is still a more attractive market for even European companies than Europe itself. Correct?
Yeah. And I think there's politics, and I think on politics is also stability.
Mm.
I think there was a discussion about like no combustion engines anymore, and then it was said like 2040, then it says 2035, and then was like the Dieselgate, and everybody was like, okay, we will step out even further. And now you have the feeling, especially in Germany, that we are turning back and forth again, and then we
Yes.
get like support for electrical cars, and then from one day to the next
The
day it's
alternative
not
fuels come
there.
up, and
Yeah,
then the whole thing. And I think this is exactly what you should, like, the responsibility of the politics to set an environment where the technological companies like you, but also where the investors know the playing field. They know the rules, and they know the general trend on the landscape where they are operating in. And I think this is missing at the moment, and why there's no trust in investing in Europe to build up new factories, to build up new infrastructure, which is risk, which takes time, feedback time. That's why I was
yeah,
asking you, right? Why you and how long your investors were patient to see an actual positive feedback. Was like, hey, it's working. We can build up something in Europe here, right? And so that was the challenges. But now I would also like to ask you, what are the key points, if you can pinpoint them? What are the opportunities? What is unique about Europe that we can do here, and where we potentially can even outperform the given status quo?
yeah. I think first of all, there's a huge market opportunity.
Mm-hmm.
So Europe is not small. We have a big market. We are
Mm-hmm.
not one third exactly, but maybe we are 25% of the worldwide demand for batteries is in Europe. And I'm speaking about all the demands of all different market
Yeah,
segments.
automotive, but also beyond stationary, consumer
Yeah.
electronics,
So
special medical applications you mentioned already, right?
yeah. So like all over these market segments, Europe is big. There's a
Yeah.
big demand, and I think if we are want to hit it, or we don't want to be like completely depending on Asia, especially on China.
Yeah.
I think we have this opportunity to build up gigafactories and like feed our own demand in the future. And also it's a great growing market. So if you look on different like consulting companies on their PowerPoint slides, you will still see a big increase in the demand of batteries in Europe, worldwide. So, and I'm not talking about like 5% or 3% per year. It's like 27% per year still.
Yeah.
And of course, if we are looking just on the mobility, we have a little bit of backfire at the moment, but also this is local. I think if you look on
If you
Germany,
yes, if you look
there's
beyond the borders, it's a different picture.
yeah, you can go to Norway. I think there's 80% of the cars, the new ones, are with a plug. So there you can see there's a lot of things going on, and I think there with some smaller changes you can get the market to the right direction. So especially if you look to Norway, why is it there's smarter to buy an electric car? Because electricity is very cheap there. So if you bring down a little bit the taxes maybe of the electricity, maybe you get the people from their own Excel file or whatever they are doing at home to the right direction, instead of like bringing some like strict things from above, like saying now you have to have an electric car, now you have to have a heat pump for your housing.
You have to make it attractive, correct?
Yeah, and then the market is going the right direction without making a lot of rules. I think if you put a lot of rules to the people, they are reacting like the Germans are actually reacting like, no, we don't want it. So
Yeah,
then it's becoming very emotional also. Like I don't want to have an electric car
yeah.
because they are forcing me to drive it.
Yeah, especially for the Germans, the car always was identified with freedom, and now you're saying, oh, range is not that, or I have to charge, like expensive, like it's limiting them, and then the politics is not leading by example, but opening the discussion for fuel flexibility or alternative fuels, and everyone's is really confused where this is actually going, and okay, but I see the point that you made is the market is big and it will be there. Nevertheless, even though the Germans are a little bit running in circles right now, but we'll get out of that. Okay. So on the entrepreneurial side, what is, or if you have some, what is your call to action to really build a business network that can make it, that can establish this European battery ecosystem?
I think we need a little bit more lobby on
Mm-hmm.
the politics side, because if like Stefan Permien from univerCell is going to the next government in Germany, so we are too small to have a real noise there.
Mm-hmm.
If you're looking on just the automotive OEMs, they have their own agenda, and it's not battery only. So
Mm-hmm.
we need more a lobby for batteries.
A distinguished network that supports the lobby.
Yeah,
Yeah.
and then we need more risk takers, more investors that are saying, okay, I will give it a try. You said the US, German or US European idea of making business. In the US, it's okay if you fail, you stand up, you do the next. And
Yeah.
I think in Europe, it's still like, okay, you are doing one shot, it has to happen.
Mm-hmm.
And of course, if we have a famous example like Northvolt, which is not working out that fine, okay, then it fails. And I read already in newspaper, okay, now the complete market is like failing.
Yeah,
But it's
and
it's
that's
not
bullshit.
true, huh?
And exactly this is
Uh,
where we need to provide information where we say like, no, guys, it's not that. It's let's build factual information here. Yes, I understand. Okay, so then the question is where you are headed now with univerCell. You're about to scale, as I know, and maybe on that's my last point. You can just give us a little outlook on where you are headed. What are the next steps? What is the vision of Stefan Permin and univerCell?
yeah, you can see some of our visions already on the table.
Yeah.
We will go to the direction of 21700. It's still for our markets a format which is standardized, which is used by most of our customers.
Yeah.
But we will not do a Me Too 21700. It will be a cell that is improving a lot, especially in a gravimetric energy density.
Okay.
So we will, like the high energy, for example, will be around 6 ampere hours,
Mm-hmm.
and it will be more than 330 watt hour per kg. So it will be very high end,
Okay.
above what you can find today on the market.
Mm-hmm.
And we are currently scaling up the production. So prototypes are available. We are shipping out to customers. They are testing, giving feedback. And then, yeah, you saw the facility here in Flintbeck. In the last year, we secured another one where we can then bring in our production. So the machines are in Korea at the moment. We
Mm-hmm.
will bring them over, by middle of the year,
Mm-hmm.
and then set up the production at a new expansion of univerCell. And
Mm-hmm.
my vision will be to produce 180 million cells in around 2028.
Okay, 180 million cells. All right. Let me allow you me a quick comment because you mentioned you sourced the machines from Korea. But what I learned today is that univerCell is not just a cell manufacturer. univerCell is actually also an engineering company who does a lot on engineering on their own machines. Of course, in collaboration sometimes with the actual supplier. But nevertheless, the German European engineering know-how on at least building or optimizing those machines is there, right? If you
Yeah.
allow me that comment.
Yeah, so you're totally right. So what you saw in our production facility is like machines from all over the world, coming from Asia, from Japan, Korea, but also from Europe, from Germany. It's a mix from everything. And what you can say, univerCell is buying basic machines and combining with different other inspection systems, for example. And what we are doing in-house is we have an engineering team for hardware and software. So we modify hardware components of the machines, and we are programming most of the machine parts by ourselves. And so also innovations are sometimes completely coming from univerCell. So we have a dry coating pilot machine, for example, which is completely designed in-house and then built up by German machine manufacturers. So the competence is here. But you have to get the experience and you have to have the time to develop. It's not nothing coming from weeks or months. It's taking years. So.
But I think we'll push through, and you give us hope. So thank you, Stefan, for this inspiring conversation and also the tour, of course. And looking forward to the next one.
Yeah, thank you very much for visiting us here in the very north with the bad weather. And yeah, wish you a lot of fun with the next stops.
Thank you.